All right. Welcome to Bootcamp, everyone. We're going to be doing a lesson on basic Python. So if you're starting coding, this is the perfect lesson for you. And Python, because Python is the most popular language used for bioinformatics because it's um, not as heavy syntax. It's user-friendly. It's easier to interpret for us, and has a lot of libraries that we'll learn about later. Um, so without further ado, let's first share the lesson details. Can everyone try going to this link and see if you can open this and if you see what I'm seeing, which is this. If you can come to this file, don't start, you don't have to start doing anything. Just if you can get here, just um, let me know. Maybe raise your hands if you can get here. If you can't, if you don't have Google Colab, then what you need to do is go to collab.research dot something. Wait, yeah, just search Google Colab and then go to Collaboratory Google Research, and you'll get Google Colab from there, and then come back to this link, and it should work. Um, all right, so if you can not get here, if you have some technical issue, then just unmute and let me know, or just type in the chat, please, so that we can start on time. All right, looks good. Still, if you have any technical difficulties, let me know. All right, so once you're on this file, you need to go to File and save a copy in Drive. So that will save a copy of this Ipython notebooks. That's what it's called, in your own Drive, and you can start working on this Ipython notebook. So an Ipython notebook basically is a combination of code cells and text cells. So this, for example, has text in it, which is markdown. So you can use markdown here. If you double click on it, you can edit the text and stuff. All right. And this is a code cell. So this very first command is just the first Python command that you'll be printing. So print, and then giving what you print just prints that stuff. All right. So just check that that works. It should work because you're in Google Colab. If you're in Google Colab, you know it already has Python. You don't have to download it, so you'll be fine. And second thing is, if a command is followed by this exclamation mark, what that means is not a Python command, it's a shell command. And we haven't done a lesson on Linux commands, but basically this is used only to maybe get files or just confirm everything is working fine. You don't have to know what these actually mean. Just printing this should give you something like root content, because this is the current location of your kernel. And if you run this cell, okay, so how am I running cells? Right, sorry. Um, so you can run a cell by either clicking on runtime or just this run button. Um, Shortcut key to run them is Shift plus return on Mac or Shift plus enter. I'll just type it in the chat again, Shift plus enter to run, enter or return. Right? So that runs a cell. Now, if you see this wheel turning, then that means that the cell is actually running. And what's happening here is that this shell thing is waiting for an input from us. So what you're gonna do is, when you just print Python 3, just having this printed just confirms that you have Python. You can just stop it by clicking on the stop button twice, and it should be fine. All right. And we're actually going to start now. Right. So yeah, there are three main objectives that we have for today's lesson. One is learning just the basic building blocks of Python, integers, strings, different things you see in Python. Then learning some basic syntax. So there's some for loops, if-else statements. We'll explore all of that. So that's the second target. And the third is to apply all of this into what we care about, bioinformatics, right? Why we are learning Python, right? All right. So yeah, you can just run all of these cells, text cells and code cells. Just keep pressing on Shift plus Enter. Keep pressing Shift plus Enter for all these cells. And the first, yeah, anything? Okay, never mind. Um, the first building block that we're gonna see is a variable, which is similar to what variable and unknowns mean in math. You used to have a variable that has a value to it, right? So here too, we use variables to store a value, and that value you can change at any point basically. And how do you store that value or change that value? So you assign that value using this assignment operator. So something as simple as x equals 5. What it does is it says that, okay, x is now defined and its value is 5. So it assigns 5 to variable x. And if you have another variable, say y, if you say x equals y, it's going to assign the value of y to x. You can even type some command or some operator. So in Python, you can, um, well, in this notebook, what you can do is you can add a code cell at any point and just start typing anything. So if I had to do just 5 plus 5, I added a code cell from there, and I'm going to Shift plus Enter to run this, and it's going to print the output, right? And I can assign this any expression, any output, anything that gives an output to any variable. And that's the magic of assignment operator. It assigns or changes the value of a variable. That's a very basic thing in Python. Until you use an assignment operator with a variable, it's not defined. So if I just print something like by, since I have not used assignment operator yet to assign it a value, say like this, I haven't done this. If I run this, it's just going to say the y variable is not defined because we never assigned it a value. But if I run y equals 4 and then I say y, then it's going to give me the output 4 because it assigned the value and then printed the value. So that's the basic thing that will make more sense as we go on. I see Calvin's hand raised. No, not Calvin, sorry. I see someone's hand raised. I just can't figure out who.
That was me. Can you
Yeah,
hear me?
go ahead. Yeah, I can hear you. Sorry.
So, so you're saying that if we don't store a value
Mhm.
within that variable, or
Right.
if that variable is stored within a different variable, when you call on the variable that's being stored into another variable, it won't give you a specific value. Like, say for example, you said x is equal to y.
Right.
So if you call on y, it won't give you x.
Well, what I meant there was suppose y already has a value, y equals 4, right?
Right.
So y has a value of 4, x does not have a value, x is not defined.
Okay.
Then it's fine because then x is going to become, x is going to have the value of y basically, so 4. However, if I use like a new variable, right? If I say a totally new variable, this is literally the name I give it, new variable, and then I try to print it, then Python's going to be like, wait, what's this? I've never seen this. This name is not defined. Does that make more sense?
Okay, yeah. So we have to and and is this just for non-numerical values that it gives errors?
Great question. This is not just for numerical. The reason why I'm showing numerical because I haven't talked about the other variables. I haven't gone into strings and stuff. So I want us to keep with just numbers because we already know about them, even in syntax. So For example, there are other variables that we'll look at very soon, very soon. So for example, I guess we just printed this thing, whatever this is, right? And if I assign this to new variable, and then I say x equals new variable, and then I print x, then x is gonna be just this. Um, these don't matter, yeah, but we'll get into that. Yeah, does that help? Great, great.
Yeah.
Yeah. So this is important to know because other languages like Java, which is what a lot of bioinformatics majors would start their coding from because of CSE 11, CSE 8A curriculum. Um, there you can define things without assigning them a value. Yeah. But in Python, definition means assigning a value, right? And on that note, let's try this. So not only can you assign one value, you can even chain your assignments. So I could say something like y equals x equals 5. And although that seems hard to interpret how the computer is doing it, but it actually does it. So suppose x is 3, right? But now I say y equals x equals 5. So if I run this, it not only assigns y as 5, but it even changes the value of x to 5. So both x and y are now 5. So that's called a chained assignment, and just shows how user-friendly Python is. Yeah. All right. So not only can you assign a new variable or a different variable, you can even, because how variables work is you can change their value at any point. Um, you can even use the same variable to find the new value of its of the same variable. For example, I know x is 5 right now, right? If I calculate 5 times 5 plus 5, that's 30. And if I assign that to x, my x is going to become 30. So that's going to be the new value of x. So I could do something like x equals something that uses a previous value of x. So I could change the x using its own value, right? And there's a shortcut. There's some shortcuts to do that. If I had to do something like y equals y times 5, Python's case sensitive, so you got to make sure you're using the right case, by the way. So if I wanted to say something like y equals y times 5, um, and a shortcut way to do that is to say y equals asterisk equals 5. So what that means is basically just this, exactly the same as this. These are both literally identical. So just multiply itself by 5, and then the value will become the new value of that variable. This is, and the same goes for the plus operator. So both asterisk and plus, and even division and subtraction. So I could say like y minus equals y. I could say y divide equals y. And what that would do is it would divide by itself and then equal and then assign that value to the new value of y. So I could say y division equals 2. So it'll just half the value of y, right? It's a bit not very intuitive at first. But the good thing is that you can just try experimenting with it, and as you see it in more different examples, it'll start making more sense, right? So does this part make sense? What if I was to say a new variable, say a equals 5, and I say a minus equals 4? um, Can anyone tell me what that would give the new value as for A? See some responses on the chat. So Willard says 1. Does anyone tend to disagree? Does anyone say, no, it's going to be something else? Because I myself, I'm not sure about this one, not going to lie. Does anyone think it should be just 5 still? Does anyone think that it should still remain 5 because we never changed A, maybe? No? Well, let's try it then. Well, look at that. So Willard was right. So what's happening here is that A equals 5, and then this line basically means A equals A minus 4. These are literally identical. All right. I'm sorry, I keep skipping a few things. Please feel free to unmute and ask me. So what these green things are, I forgot to mention that. Calvin, you also please make sure I don't skip things like this, because I'm already used to them and it's hard to just, you know, remember to point these little things out, because after some point you won't see this thing as like something you need to learn. It kind of becomes very intuitive. Um, so just gonna mention that all these green things are what we call as a comment. Any line that is followed by a hashtag, or basically anything that is followed by a hashtag, is a comment. So I could say like 5 plus 5 and then hashtag, and then this is what my comment is. If I run this, it's going to print 10 because it's just going to ignore all of this, since all of this is a comment, and just going to print 5 plus 5. And you can comment a line by just typing a hashtag. You don't have to even give a space. Anything that follows a hashtag is a comment. Another way to do it is to select the line or lines and then click on command plus slash or control plus slash. So that will toggle the comment. Right? You can all try it on your own notebooks. There's other tricks. If you can select a text, you can move it to the right by pressing tab, shift plus tab. But those tiny details, you just get to know them with time. You get a hang of them with time. I think it's important to understand what comments mean though, and how they're in the code cell. They're in the code cell, but they're not code themselves, because they are not commands that Python is going to be running. They're just for the user, just for the coder. Right. So more about the variables. Each variable is coming from a class. It has a class, it has a type. And that makes sense because even in math, we have fractions, we have integers, we have imaginary numbers, we have all these different kinds of numbers. In variables, and when we talk about variables, they're not only numbers, they can be literally anything. So for example, let's look at y. So if I say y equals 5, and then ask Python, what's the type of y? It says int, which stands for integer. A function that can help you learn about that particular class is help function. So I'll talk more about functions later, but anything that encloses some input in parentheses right now is a function. So basically typing help and then enclosing the variable in parentheses will give you a synopsis of the class that that variable belongs to. So if I run this, it's going to print the whole class int information on the class int. So you can see integer, you can see how there's an option to set a base. We don't really care about this, but it's just good thing to know that if you don't know about an element, if you don't know the class, you can go do type by, or you can do help by, and that'll give you the type of that object, right? Another way, which works only in Collab and Ipython notebooks, not in Python files themselves, is this question mark. So if I said z equals 3.14, what is the type of z, and what is z basically? If I run this, the Z question mark, sorry about that, Z question mark is going to open a help page over here, which says type float, string form 3.14, which basically means what this variable looks like, 3.14. That's what it looks like. And the type of Z here is also float, like just like it says here. So basically all the decimal numbers in Python are float numbers, are float variables, right? So integer and float are the two types that we have seen so far. A third type is a Boolean. Booleans are basically just two objects, true and false. So there's only two objects in the Boolean class, true and false. And when we talk about Boolean, we're basically talking about conditions. So if I ask, is 5 greater than 6? Is that true or is that false? Well, 5 is um, greater than 6. Is that true or false? So we're going to
False.
assign, yeah, we know that it's false. And Python also has an object for that, right? So if you assign this condition, whatever this is, whatever this thing is, all right, it's an object. If we assign the value of this to A and then print first A itself and then the type of A, running this will give you, well, A is false, and this object is from the Boolean class, from Bool class. This is what the class is called. So we have seen three objects. We have seen int, sorry, we have seen three types. We have seen int, float, and bool. And you can change the types of variables. So if I say int 3.7, 3.7 is a what? A float, right? 3.7 would be a float, but I can change it to an integer. And even a Boolean can be converted into an integer. And an integer can be converted to a Boolean. So yeah, so you can change the variable types. That's what the main point is. When you do int 3.7, it'll just change it to the integer, I guess the non-decimal part, the integer part of that decimal. And false is 0. Always remember that. Anything non-zero is true. So if I said Boolean of 3, it's true. But if I said Boolean of 0, it'll be false.
I have a question.
Yes, please. And
So,
actually, I was just going to say, any questions?
so integer 3.7, so the integer became 3.
Yes. So int 3.7 became 3
Integer
and
false became,
0.
why is that?
Right. So let's look at them individually. Let me just remove this for now. Let's just look at int 3.7, and that's 3. Does that make sense? Or or do you want more explanation on that part itself?
No, that makes sense. It
Okay.
just,
Right. So I again skipped something. Right. So in Python, what you can do is instead of returning just one object by itself, you can add a comma and another object, say int of 4.5, and that will return this whole thing enclosed in some brackets. It'll return like both this item and this item together. So if I print this, it'll give me 3 and then 4.
so it doesn't round the numbers. It just gives you the whole number
Yeah, so when you
for the
when you go
first
from
portion.
float to int, it does not round them. It does not round them. It takes the integer part of those numbers. It's not rounding them. It's not approximation. It's just taking the integer part, the whole number, the floor of the number, basically.
So the comma allows you to do multiple commands at once.
That is it. That is exactly correct. Yep. So I could say comma, um, 2 plus float, or I guess int of, or I guess, yeah, float of 3. So what will that print? Float of 3 would be
3.0.
3.0, and 2 plus 3.0 would be
5.
yeah. So it's just going to print 5.0 for the last one. That's a great observation. Thanks for helping me. It's, yeah, I'm trying my best to like not skip on these little details. But it's great when you point them out, because what might be intuitive to me might not be intuitive to someone else. This is a great thing to notice, because this is only in Python that we get this, right? So you can print all of these together, and it'll print all of them one by one, 3, then 4, then 5.0, like that. All right. So Peter asks, could you add comma A? Yes, I totally could, because A is already defined here. In all these cells, these are just running the command, but the variables storage, like the variables values, everything is being stored in the kernel, like something in the background. So A is still very much defined here, because we have run this cell already. So if I run that, it's going to give me, oh, sorry. So I'll just remove print stuff. So if I do that, A was false, right? A was false. And the last thing here, which is A, is false. So yeah, I can add any variable. I can even add Z. I can add int of Z. So it's Z was 3.14, int of Z becomes 3. Yeah, take a moment to absorb this. It's okay. Any other questions? Any other thoughts, discussion? What questions do we have?
Could I ask a question quickly?
Please go ahead.
So you're able to do that without a print statement? Is that only for this notebook, or?
Yeah, that's a great question. So when I'm in a notebook, when I run a cell, the last output that this cell receives, right, that's gonna be outputted. It's not exactly printing the output, it's outputting the output. So for example, if I said print Z, okay, so what's the difference between the first and second line? The first line is printing the variable, maybe add another variable, Z and A. So this is printing the variables. This is outputting the variables. So if I run this, the difference is that this is just plain printing them without like commas, right? And the last line is showing me the object. It's printing the object. This whole thing is an object in itself. It's called a tuple, but right, step by step. So this whole thing is an object. So that's what it's outputting. Great question. And it won't work if I did something like this. If I have something outputting here, and then if I gave a print command after that, now the last output is not this. The last output is what the last output is in this line, but print does not give any output. Print just prints the variables. So when I run this, I'm only going to see Z and A being printed. There is no output.
Okay, that makes sense. Thank you.
Sure. Great questions. Yeah, let's help each other here, because we all have different kinds of intuitions, different things we've seen. A lot of these stuff are intuitive because of what we've seen in math or maybe other programming languages. So what might seem intuitive to you might not be intuitive to others. And if something is not intuitive to you, there might be others who are struggling with it too. So please speak up and please let me know. All right. Are we ready to move to strings and lists then? So numbers are the type of variables what we saw so far, and Booleans, right? Int, float, and so int, float, and bool. Besides that, we have these other variables which contain variables inside themselves. So it's like a variable containing a variable. And why would we do that, right? So let's talk about strings first. What's a string? Whenever I say a word like hello, it basically is a collection of letters, right? It's a collection of letters like H, E, L, L, O. So it's a combination, or as we should probably use the word, a collection of characters. And that's what strings are, that they are a collection of characters, which could be letters, they could be numbers as characters, not numbers, not these numbers, but character numbers. So like enclosed by these single or double quotes, single or double quotes, either is fine, it doesn't matter. So this is a string. This is also very much a string. This is also a string. A single character is also a string because characters are also strings. They're just single character long. Even this is a string. A double quotes in a single quotes is also a string because double quotes is a character in itself. And a single quote in double quotes is also a string. So any collection of any characters enclosed in either double quotes or single quotes is a string in Python. And you'll typically see this in this reddish brown color. So actually, we have already seen strings so far. So whatever these outputs that we have seen, these are all strings. These are all strings because Python, when it takes the print command or outputs something, it outputs the string representation of that variable. Whatever it's printing, it just prints the string representation of that. So for example, let's make a string out of 4.5. So just how we were doing int of 3.7, int of 4.5, we can also convert a float to a string. Instead of typing the whole word string in Python, str is the keyword for string. So str 4.5, this is converting 4.5 into a string. And what's that string going to be? It's going to be the string representation of that variable. So if I print this, right, if I run this cell, and if I output the string representation of 4.5 and the type of that string, it's going to print 4.5 in single quotes. So if it's in single quotes, it shows that it's a string. And also the type of the string is a string. Interchangeable. Are there different applications or functions? So single quotes versus double quotes, there's no difference. There's literally no difference. There used to be difference in other languages like Java. So it's, I guess, a bit of a legacy, but basically you can use either. They mean the exact same thing. And you can use them interchangeably in any application at all. Just make sure that, suppose I'm typing a string like something enclosed in double quotes, right? Whatever here is inside, I'm typing it, but then I have a double quotes. So what's Python gonna think is that my string ends here. However, if I had single quotes on the outside, so like this, now Python is gonna wait for another single quotes to close the string. So it's not gonna end here, it's gonna end here. So yeah, try experimenting with that. But remember that these are interchangeable. But you cannot use a single quote with a double quote. If you start with a single quote, it'll wait for another single quote to finish the string. And if you have a double quote, it'll wait for another double quote to finish the string. Right. So we said that strings are collections of characters. In fact, they're a list of characters, which is the same thing at this point, right? So, but let's start thinking of this as a collection and not just a word. So this string has 1, 2, 3, 4, 5, 6, and so on, 11 characters. H, E, L, L, and so on up till R S exclamation mark. Don't worry about this cell, just run it and you'll see this output. And why I'm printing this out is because I'm just making an index for each of the character in the string. So the 0th character in the string is H. The character at index 1 is E. The character at index 2 is L. At 3 we have L. At 4 we have O. 5 we have a space. 6 we have M. 7 we have A. 8 we have R. 9 we have S. And 10 we have an exclamation mark. Now, your index starts from a 0. And why is that important? Because we can actually access any character in that string using just that index. So my string is hello Mars. If I print my string and then in rectangular brackets I say, or square brackets I say 0. So it's gonna print the character at 0th index, which is what? This one. So it's gonna be H. So this line is gonna print H. And then if I do my string 7, do you try to guess which character is gonna try to print? Can you try
A.
to? Oh, sorry. Can you repeat that?
A.
Yep. So it's gonna go for this index, and it's gonna look at A.
I have another question.
Sure.
So enumerate is a function, right?
Yeah, it is a function, but honestly, that yeah, you don't have to worry about what it does exactly. But what's your question?
Yes, but it allows us to number
Yeah.
each letter or each character in our string.
Yep.
So which
Exactly.
is why the results give the number beside the character it represents.
That is exactly correct. Yep. That's nice intuition. Your Python sensors are working. Great.
But
That's great. Yeah.
how do how is it allowing us to do that by saying for X in list if we
Yeah.
haven't
So
defined what the
I know
list is?
those are some details. So basically this enumerate is an object which needs to be converted to a list. And if I was to print this list by itself, unexpected. Oh, then it gives me this list and I'm just printing every element of that. Yeah, but I'll get into the syntax and I will promise you that by the end of the lesson, you'll be able to make sense out of this. By the end of this lesson, I mean. That said, if we can finish by today, that is, hopefully we can, yeah. But by the end
Okay,
of this
thank you.
lesson, you'll be able to understand this for sure. Yeah, I want to emphasize on right now. Right now, by the end of lesson, you'll be able to understand this. Right? So indexing is, so we index, like we can access any character in a string using the index by putting that index in square brackets. And then another thing with strings is you can print the length of that string by using the len function. So len stands for length. And if you ask Python to comment all of this, and if I just say len of my string, then it's going to output 11. That's how many characters there are in the string, right? And then you can even use negative indices. So negative indices mean? So when we start from 0 and we go all the way up till the end of the string, negative indices basically means going back. So we're going back, starting from -1, -2, -3, -4, and so on. So if I print this, at -1, I have the exclamation mark. And at -4, so -1, -2, -3, -4, it prints an A. I know it seems like, why am I being shown this? How is this going to be useful right now? But it's going to make more sense as we start to use them in cool bioinformatics problems and like things that can be useful for our own labs even. Because I mean, for example, you might have a long DNA sequence and maybe you just want the end 10 letters of that sequence. If you had any sequence, say like seq, for example, it's a variable which has a very long DNA string. So all you have to do is index, and this gives you the minus, this gives you the last letter, this gives you the second last letter, this gives you the third last letter, and you can just use that to get the last 3 letters of a very long DNA string. That can be useful sometimes. And yeah, so we'll see some more cool and more useful applications than that even in this lesson. Right. So just like strings are a collection of characters, we have lists which can collect literally anything, any variable. So they can even have a mismatch. So they can even have different variables. So for example, um, this is a list. So I know this looks not as friendly as a string does, but let's try to understand. So in this list, it starts with a square bracket and ends with a square bracket, and all the elements are separated by commas. So in this list, we have 2 elements, cool and is. So these 2 strings are what this list contains. If I was to comment out everything here and then just run this, it'll, and then I ask Python, hey, what's my list? It will print cool and is, right? And you can do very similar things that you did to strings with the list even. So for example, you can do what's the length of my list? 2, because it has 2 elements. And what's the first element in this? So I'm going to say first, but the index starts from 0. So I'm going to say my list 0. That's what's going to give me the first element of this list. So it'll say cool, right? That's how, does it make sense how we're using indices to access elements from a collection? All right, I'm going to uncomment all of this now. Let's look into this. Yeah, so the first item cool is at index 0. We're going to use this actually here. All right. In both strings and lists, you can add characters, you can add elements. So for example, let's look at this string first actually. So this is one string and this is another. I can add them to what we say concatenate them. So this is what's called concatenate. Just combine them. So it combines them literally. It just says BIO, INFO, and so on. And if we have plus, we also have plus equals to, because what that is going to do is it's going to take cool is and then add bioinformatics to it. And this new list will become the new value of my list. So if I comment everything here again, and I ask Python, what's my list? It'll say cool is, and also bioinformatics. So that's how you can add stuff. Not only can you, okay, so Peter asks, would accessing the index of 3 or -3 for cool be out of bounds? So yeah, what is out of bounds? All right. I'm accessing the elements that do make sense here. My list here has 3 elements. So it does make sense to collect the first element. It makes sense to collect the second element. It even makes sense to collect the third element. Third element, so index 2 element, 0, 1, 2. So what if I did something like this? Does it make sense to get a 100th element from a list that's only 3 elements long? Let's see what Python says. So Python does give an out of bounds or an index out of range error. And the same will be true for a list. So for example, if I said 1, 2, 3, 4, so it has literally 4 elements, 4 characters. And if I try to access the 5th, so if I try to access the 5th element, which is at index 4, right? 0, 1, 2, 3, 4. And if I run that, it's going to say string index out of range. But if I do the 4th element, so 0, 1, 2, 3, then it's going to print 4, the last character here. Great point. Right. Besides using the plus equals to add an element, there's a function for it. It's called append. Append basically means attaching at the bottom, at the tail. And that's what this is literally doing. It's going to append an exclamation mark to the list. So let's try to run this. Mind that plus equals, for plus equals, I'm basically adding 2 lists. Using append, I'm adding an element to the list. So here I could have even made it something like another element, right? And if I print what my list is now, at this point that is, and I comment this, it's going to say cool is bioinformatics and whatever the other element is. So essentially you can add any 2 lists of any sizes. But when you use the append function, you're appending a single element to the list. So if I say Python, what's my list now? It's going to say cool list bioinformatics that element and exclamation mark. So it's appending that element to the list. It's not adding a new list. It's appending that variable to that very list. Right. So we can print the list, and we can even print the element at index 1 of that list, element at -1 index of that list. Let's try to get that. So this is the list. We have cool is at index 1. So we have 0 and then 1. -1 is going to be the last element. So that's the exclamation mark. So we start from 0 when we start from the top, and we start from -1 when we're starting from the end of the list or the string. Right. Now the first item is cool, right? We can use this operator equals equals, which is basically the equal sign from math. Since we are using the equal sign itself as an assignment operator for Python and other languages too, we use double equal signs as our equality operator. So equality basically means if the thing on the left is equal to the thing on the right. So my list 0 is cool because 0 index, right? So the first element. And that is equal to this string. So if I run this, it's going to print true because it sees. But if I say cooler, then cool is not cooler, right? So it's going to say false. Right. And we saw how concatenation works. Not only can you add strings, you can even multiply them by a number to add the same string repeatedly. So if you say cool with O multiplied by 2, it inserts 2 O's and makes that word cool, makes that string cool. If I made that 5, it'll have 5 O's. And then if I said 100, then it'll have 100 O's. And in this example, it shows that the same works for a list as well. So not only can you use this for a string to keep on adding the same keep on adding the same string. So if I said like double O, and if I made this number 3, it's gonna have 6 O's because it's repeatedly adding OO thrice. And I can do the same with the list. So in this list, I'm gonna repeat super n times. If my n is 0, then it's just not gonna add this. And my answer would be bioinformatics is cool. But if I make n 20, then it's gonna say bioinformatics is super, 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 super cool, right? Does that make sense so far? Any questions? What questions do we have?
I have a question.
Yes.
So why is it that we put each string in a bracket?
In a bracket, do you mean the codes? Or do you mean this bracket?
Yes.
Sorry, the square bracket. So we're putting this in a bracket because this is a string, but this is a list with a string in it. So I could say like bioinformatics, and I could add another, maybe a number, maybe a Boolean, maybe anything I want. This is a string. When I put rectangular brackets with either just one element or multiple elements separated by commas, it's a list. So all of these are actually lists that I'm adding to each other. They just happen to have single string element, and that can be a bit confusing, but it's good to take note of these things. If I did something like this, then I'm adding the strings now. So bioinformatics is super, super, yeah, it's just combining all these strings. But if I put them in the brackets, then it's going to make a list, a new list with all of these elements. So bioinformatics, then is, then all the supers, and then at the end, cool. So it's combining the lists, not the string. So that's why I just wanted to show an example of combining lists instead of just strings. So that's why I put them in lists, just to show that you can even do the same thing with lists. Great point, great observation. Any other questions? Any other things you want to discuss? Anything you want me to try, maybe? Okay, soon I'm gonna ask you to try something though. So we have list and string. They seem so interchangeable. They're so parallel, right? They are both collections. They can have different things. Especially if it's a list with strings in it, it almost seems like I could like just replace the brackets by nothing and then convert it to a string, something like that, right? And yeah, they are very interchangeable. They're very much interchangeable. We can go from a list of strings to a string, and we can go from a string to a list of strings. So for example, this list is bioinformatics, then is, then supers, then cool. This is a list of strings. So it's a list because it has brackets, but the elements are themselves strings. I could join them and convert it to a long string of itself. So for that, you can use join function. And I think this is pretty helpful for like, it's just good to know. What join function does is you take a string, you first take a string, then you say dot join, and then you give a list. This string is what you use to join the elements of the string of the list. So this is a separator. So if I print this, it's going to print all the elements of that list combined into a string. And all of those elements are separated by this delimiter or separator. So I could say, if I do a modulus sign instead, then it'll combine all of those elements with that sign. So that's what join is doing basically. Right. Right. So string to list is even easier because all you have to do is just list of that string, just how we did int and float and string of numbers. You just have to literally say list of that string, and then it'll convert the string into a list of characters, literally. Right. This is something cool and kind of trippy. It's kind of trippy, but looks it just kind of helps you solidify or test your concepts. So in here, what we're doing is int of 5.5 equals 3.5 plus 1.5. This whole thing, string plus string of 4.5 plus 0.5. So this is 5, and this is also, is this 5? This is actually 5.0, but they're still equal. And that's some good thing to remember. So even though this is an integer and this is a float, they are very much equal in Python. And then the string of that is true, the string true. So TRUE, and then when you add string representation of 5.0, which is the sum here, it becomes true 5.0. Right. All right, so what we're gonna now go into is so what we're gonna now go into is a more difficult or a more advanced way of accessing the elements. So far we accessed elements of a string or a list using just an index number, right? What if we wanna access different parts of a string? So instead of accessing just one character in a list, we want to access this subsection, like the first 5 letters, last 5 letters, 29th to 30th, or 29th to 40th elements, you know, something like that. So that's what is a range. It can be used with a string, a list. I say array here, but like array, list, string, anything that I can iterate over basically. And this is a golden rule that we'll learn. Start, stop, step, okay? So for example, this is a string that I have. 0, 1, 2, 3, 4, 5, 6, 7. These are all 7, or I guess these are all 8 characters, and this itself is a string. If I did something like this makes sense to you. Oh yeah, that's the first element of the string. So that's just gonna be 0, right? And if I did 4, you would say, yeah, so that's gonna be the 4th element. And with a string like this, it's easy to say, yeah, that's the 4th element. So 0, 1, 2, 3, 4. So 0, 1, 2, 3, 4, 4th element here. But what if I want the first 4 elements? So I would say 0, 2, 4. That's how it's read. Start, stop, separated by colons, and I don't have a step right now. It's separated by colons. When it's separated by colons, it means that I'm talking about a range instead. And you don't have to worry about step right now in this example. We're going to go from 0, 1, 2, 3, and then stop at 4. We're not going to include 4. It's going to be exclusive. The start is inclusive. The stop is exclusive. So it'll go from 0, 1, 2, 3, and then stop at 4. Let's try to print it. 0, 1, 2, 3. Take a moment to kind of digest that. It's a bit non-intuitive at first. So yeah. Yeah, ignore all of this. This is a different example, I guess. I think this is Hello Mars, actually. Yeah, you can do that too. Hello Mars. The first number is the position of the first character. 0 is H. So if I run this, what do you think the output is going to be? Try to think of that. So the first character is definitely H. Then it goes and takes 1, 2, 3, 4, 5. Does it include the space or does it not include the space?
Not include.
Exactly. So well done. So stop is going to be exclusive, right? So it's going to not print the, let me make this 6 because then it's going to be about whether it's going to include M or not. So when I print it, it'll actually appear. So it's not going to include M in this case, but it does have that space, right? And if I say 0 to 5, it's not going to include the space. See, I'm trying to, yeah, it's hard to show, but I'm trying to basically select the whole thing and it doesn't have a space. Right?
So it does include the space.
Oh, so if I did 0 to 6, then it'll include the space. You were right though. When I did 0 to 5, then it'll include the space because now I'm going till 5 and then stopping at 6. Yeah, but you were right. When I say 0 to 5, then I'm stopping at 5 and it's not including the space. Sorry for that confusion.
What happens if there is a space that's included?
If a space that's included, as in like, you mean like this case? If I remove a no?
Yes.
Yeah, so it'll print, if you select the whole thing, right, then it'll have that space. It's basically, so in Python, Python doesn't care what character is it. It doesn't care it's an O or an M or a space. It's just about printing the characters. Yeah, space is nothing special. Space is not special. It's just like any other character. So if I say 0 to 5, it's going to print first 5 characters, and it's going to stop at 5. So 0, 1, 2, 3, 4, and then stop at 5. If I had the O, it's basically like this, what we saw above here. So if I say 0 to 5, 0, 1, 2, 3, 4, and then it stops at 5. So this is what you should visualize, that it just stops at 5. It does not print this variable. It stops at 5. Is that awesome? Right. Lots of scrolling here, sorry. Right, now we have seen start, we have seen stop, and we have seen index by itself without any colons. Let's kind of apply that. So my string is hello Mars. My list is cool as bioinformatics. This is a string, this is a list, as the name suggests. My string 0 to 5, what will that add? And then whatever that is, that plus a comma. Right, so before I go into this, I need to just remind you that what print function does when it has all these different inputs, all these inputs separated by commas, is that it takes whatever that element is and then it separates all of them by spaces by default. So actually, you know what, I'm going to use concatenation instead of these commas first to show what it would be like without print adding spaces of its own. All right, so what it does is it takes the first 5 characters of this. So 1, 2, 3, 4, 5, hello. Then it adds the comma. Then it takes the second element of, well, the index 2 element. That's what I usually try to say. So index 2 element of list. Then adds the index 1 element of that list, and then index 0 element of that list, then the last character in that string. So that's what the result looks like. If I have commas instead of plus signs, then it's going to add just spaces of its own. Yeah, don't worry too much about that. Yeah. And just let's just see this again. So type of this list is just list. Okay, then the length is 10. And if I say 3 to 6, it's going to go 0, 1, 2, 3, right? It's going to start at 3 inclusive, 3, 4, 5, and then stop at 6 exclusive. So it's just going to take 3, 4, 5. Try to absorb that. Right. And so yeah, we have seen start and stop now. We also have this range function that basically what range function does is it builds something very much like this. Like it basically builds the indices that this would build. So for example, if I was to say a range of 10, it'll just go make a list of the first 10 numbers. So let me print this as well. So range 0 to 10. If I say like, what is the third to sixth element of this range? It's going to say range 3 to 6. But if I say particular indices, what's the ninth element? Then it'll start to make sense. So the ninth element is 9. Third element is 3. What's the last element? 9. What's the first element? 0. So what it's doing is that it's right. It's if I print the first 3 of these, so it's taking 0, 1, 2, and so on up till 9. And a better way to look at this is to convert the range into a list. And how do we convert it? So we can use the list function, just like how we saw it, or how we saw earlier in case of list for a string. And it converts that range to a list. Typecasting. That's what it's called. Typecasting, changing type from one type to another, right? So now this range becomes, yes, go ahead.
What would it be if we just did range 10?
Range 10, right? So that's what we had here. So that's a range object. You see, type of this object, this range object is just range. It's an inbuilt, it's a variable type that we can't interpret as easily as a list, but it's what it is. It's a class range. You can build classes of your own even. So it prints that range as the first, as range of first and then the last. That's what it has as the string representation. That's what it prints for that range object. Essentially, it contains all of these objects. And I get these by converting that range into a list, as I did here and here.
No, what I'm asking is the range in the form of a list? So when you run the command range 10, does it give you a list of the 10 numbers?
Right. So range of 10 does not give me a list of the first 10 numbers exactly, but something very similar. Right. So it gives me something that can be made into a list of the first 10 numbers. It contains the first 10 numbers very much, but not in a list. In a range object. The way we can print the list and it shows all the elements, range object does not allow that. Range object just prints something like this. And in order to see all the elements at once, I need to print them out by first converting that range into a list. Or as we saw earlier, just printing each element literally by accessing them by index. Does Does that make more sense? Does that make more sense?
Yeah.
Yeah. Wait, what?
Can we run just range 10 and see what that?
Range 10? Yeah, sure. So let's see. That's a great way. That's a great way to go for it. So range of 10. Right. So that's just the range object, you see. It's
Okay.
like a list, because if I say, okay, range 10, give me the fourth number, it'll say 4. So it contains those numbers, but it's not a list. It's a range object. It doesn't print all the elements like a list does. But if I convert this range to a list, then you can see that it's very much like a list.
Okay. Thank you. I needed to see it in order to.
Yeah, I get that. It's great. It's great the way, this is the way to learn. I think this is the best way to learn. Just keep outputting all these variables, all these different things that you see, just keep outputting them. Keep outputting their functions, outputs, and keep looking. That's the way to learn Python, I think, or any other programming language, I think. Just keep checking what they are. And it's easier in Python because Python can print basically anything. Right, so we need the lists because we cannot see the range. And we will convert that range to a list by just using list of function, the list of range, I guess. Then we can again access a range of that list, or I guess a sublist of that list by using the start and the stop. Right. Just to kind of, I guess, build an intuition, although it's not very intuitive what for is for some of you. You could also do this by, so another way to print everything inside a list is to use this. So what I'm saying is, for anything inside this list or array or string or range, X, whatever that element is, a list containing X, such that X is every element in that list. If it makes sense to you right now, well and good, but we'll get to this part in a bit more detail later. This is just to print it out, basically. So even if this was range 10, right, if I run this, if my list array is range of 10 and not a list, so I'm not running this, I'm gonna, okay, let me do this. So list array is range of 10. And if I print everything in it, it'll print it like this. And we'll look at for loop and list comprehensions in a minute. Right. Okay, let's start. Let's go. So 0 to 9 is again going to print the same thing. It's going to print 0 to 9. Well, sorry. Let me run this, and then this. Yeah, it's important to run these cells in order. Otherwise, you can have some technical faults, some bugs that you don't want to have. So make sure. Okay, so far what we saw was 0 to 9, right? You could omit that 0 because by default, the start is expected to be 0. So if I say just :9, it'll give the same thing as 0 to 9. If I make it 0 to 4, it'll give the same thing as :4. Get my point? Does that make sense?
I have a question.
Yes.
So in line 105, you have X for X, Y X for X.
Yeah, so I know that seems a bit trippy, but I'll talk about the list comprehensions in a later part. This is just to print out the elements. Yeah, we'll come to the list builder and this notation in a minute. That'll be the for loop section, basically. All right. Sorry about that. I know that was just to print out the different elements and just show you that the range does contain all those elements very much. It's just that um, um, it's a different object, basically. It does not, the class is defined in such a way that it does not print all of the objects. Yeah. The reason is a range is built for like containing large lists. So that you don't have to worry about printing all of them at once. Yeah. All right. So 0 to 4 and :4 mean the exact same thing. And this second colon is what brings the third thing of that golden rule: start, stop, and then step. So :5, :2, what does that do? It gives me 0 to 4. Step basically means that, let me print the whole thing first. And then I can show you what that means. So step basically means I'm skipping every second element. I'm skipping by that step. So 0, I skip 1, I include 2, then I go again. So 1, and then I include 4. And I do that until I reach the index 5 element of that list. So what's the index 5 element of this list? 0, 1, 2, 3, 4, 5. So it's not going to include 5. It's going to stop at 5. Having a step does not change the stop index element. The stop is going to be the same. It's just that within all those numbers between the start and the stop, it's going to step by, instead of a 1, it's going to step by that particular given step. So if the step is 2, such as here, it's going to go 0, 2, 4, and it's not going to go beyond the stop. So if I increase this to 100 even, it's not going to give me index bounds. It's just not going to stop until the end of the list. It's going to go 0, 2, 4, 6, 8, no bounds. It's going to go till 8. And step can be negative. So if I make a negative step, what that will do is it'll start from the reverse of the list. So let me make it a bit more clear. Maybe 1, 2, 5. So 0. Right. So let me start from, say, 8th element and then go till the second element. -2 basically means going in the opposite direction. So I can start from an 8, then go to the like 2 elements down, and 2 elements down again until the second element of the list. That's where I stop. So my start and stop are opposite now. So if I do this, it'll be 8, then 6, then 4, and then 2 will not be included because I'm excluding the index 2 element of that list. So I'm stopping here. But if I did not have this, then by default, the start will not be 0 now. It'll be the end of the list. So it'll start from 9, then go to 7, and then go to 5, go to 3, but then it will not go beyond the stop. So it'll be 9, 7, 5, 3, and that's where it will stop. Right. Now, I'm going to wrap up basically here pretty soon. So I'm going to go over if-else statement. And this is something that you can try on your own, getting the reverse of a list. So a small hint is that you need to use your colons. And that golden rule will be very helpful. And you need to use and try to use as minimum numbers as possible. Okay, if-else statement. So if and else is something we use in daily life. Suppose I say, if it does not rain, I will go to the party. Else, if I have more than 2 tests, I will study. Else, I will sleep. So what are we doing here? So it does not rain is a condition. If that condition is true, I will do what I said in this sentence. If uh, this is also a condition, if this is true, I will do this condition. And if all of these conditions are false, then I'm gonna resort to the last default option, which is I will sleep. And that's if, else if, and else. These are the 3 keywords that you need to remember for using different pieces of code, different branches, like this or this or this. So 3 different branches, 3 different things I could do. I could go to the party, I could study, I could sleep, depending on some conditions. So let's try to convert this to Python code. Suppose I know this variable stores the value if it rained or not. If rain equals true, then it rained. If rain equals false, then it didn't rain. And number of tests is 2. Suppose, for example, start with. I can change that to 4. I can change it to anything. We'll try the if else outputs with the 2 variable values changing. Okay, so let's try to say, I'm going to actually just remove all of this so that I can start kind of writing this or translating this in Python code. First of all, if, right, then the condition. The condition is not rain. So literally not rain. What not rain does is, this is an object in itself. Let's first see this. So not rain is just the opposite of rain. So if it's this, if this is true, it prints false. And if this is false, it prints true. So if this condition, right, not rain, I don't have to enclose this in parentheses. I can just use it by itself. If not rain, then I will go to the party. Else if, which is what elif means, if the number of tests is greater than 2, right? So number of tests is greater than 2, strictly greater than 2, then I will study. And if these conditions are not true, then I will just sleep. So if it did rain, number of tests is greater, number of tests is 1. What will the output be? If it rains, I will not go to the party. I will, and if I have less than 2 tests, I will sleep, right? That's just the natural flow of the dialogue here, or I guess the monologue here. If you print that, that's exactly what it says, right? So it enters this branch first. It checks the condition. If not rain, since rain is true, this condition is false. And if this condition is false, I'm gonna not go to this block of code. I'm gonna go to the next else or elif. Then it checks else if. So since this is not true, it goes to else if, and then it checks do I have more than 2 tests? Well, the number of tests is 1, so I don't have more than 2 tests, so it does not enter this. If I change this to, oh no, I have 100 tests, then I need to study, right? So I'll not enter here, but I will enter here because 100 is greater than 2. So I will print this, right? And as we saw in the previous case, if I have like 0 tests, and it does rain, sorry, it doesn't rain. If it doesn't rain, it doesn't matter if my number of tests says 0 or 100, it's party time, because if it does rain, I'm just going to enter this block of code, this branch of code. That's what else if, and that's what if else if basically means. This is how you should use them. So this is a bit of the syntax, right? And since we are reaching now 2 p.m., we've actually already reached 2 p.m., I guess. I'm going to wrap up for today here. I've clearly not been able to finish the lesson, but I think the more important part was just going over this as much as I can. And for the next part, for loop, then this small activity kind of, we'll continue this next week um, in a like a I guess a backup bootcamp session. I'll send the details for that session later. I'm so sorry. I knew that this is a lot of material, and I didn't know um, what kind of people, like what kind of backgrounds will the people have, and how much time will I have to spend. It's hard to gauge that kind of. So we can continue this next week. And Candice asks, where can we access the recording? So for the recordings and notebooks and all the bootcamp resources, basically, um, you'll find this sheets useful. I'm going to put that on the chat. So try to use this link. Maybe let me try that quickly. Actually, I think it should work. Yep. So I put it in the chat. It's also on the Discord announcement. That should also work.
The chat doesn't show on my
Oh, sorry.
end.
I'm so sorry. I PM'd someone. Sorry. Yeah, sorry about that. So that link should work though. And of course, since I wasn't able to complete the lesson today, I'm gonna, let's see, I'm gonna like change the schedule. I think we have like 2 workshops next week and next week. So sometime in the next 2 weeks, we'll have like a shorter, like a just an hour long bootcamp lesson in which we can complete the rest of the lesson. It'll be just hour long, and it'll, yeah, we'll release the details for that, like by Tuesday for sure. Yeah. For loop, and then the functions and this challenge. It'll be fun. It's a fun part. Yeah, please come to that. I'll release the details for that on Tuesday. I'll try to adjust it so that it works for everyone. But yeah, thanks for coming to the bootcamp today. Thanks for your time. I hope you learned some basic Python and are excited to learn more of Python and solid, make your basics solid. Yeah. Yeah, the recording will be on that Google Sheets at the end of the meeting. I'll put that there by today. Yeah. Any other questions, any other concerns, any doubts? All right, so Peter says in the strength section, there was, what is that? Okay, we can talk about that. Let me share my screen again. Did I just share the wrong screen? Oh, never mind. Wait, got my notebook closed, I think. Okay, there we go. Can you see the notebook now? Wait, where was it again? Here, there we go. So what is this doing? Okay, so what this is doing is, first let's see what this is. Okay, let me just try to print this first. whatever this thing is, it's assigning whatever this is to a variable that's just called underscore. Underscore is just used to indicate that the variable is not useful. I could technically like label it like a useless variable because I don't care about this list. Okay. What's happening in this list comprehension is that for each element of this list, it's printing that element, right? And then storing the output in a list. But since print does not have any output, if I was to just output this whole list, it'll output a list of nones because print does not have any output. So I don't care about this object, right? So I just said underscore equals. It's a Python trick. Yeah. I've often seen like what people do is, suppose I have something that returns like suppose I have a list. Okay, suppose I have a list 2, 3, and 5, or like useful, and useless. So I care about the first two elements of that list. It could be a tuple, it could be anything. What I can do is I can assign 3 different variables, x, y, z. And what it'll do is it'll assign each of these variables as each of the element of this list. So if I print x and y and z now, it'll say x is useful, y is useful, z is useless. And since I didn't have to use z, what I could have done is I could have said something like this. So since in my code, I won't be using underscore this, since this is a useless variable, it's, I guess, a common, what do you call, it's a convention to basically indicate a variable that you're not going to be using with an underscore. Yeah, so that's a convention basically. If you're not going to be using a variable, but you still want to, maybe you want other things being returned, or maybe you have something that is calling a function. So it's printing the output. So it's calling the function, but it's not outputting something that I need to use. So the convention is to use an underscore for that, basically. Yeah. Yeah. Any other questions? That's a great question, by the way, Peter. Thanks for bringing that up.
So that's a variable you stored the printed list
I
in?
see. Yeah, I see Peter's point now and looking at the chat. Yeah, it looks like something like plus equals, but it's not. It's not. Yeah, it's not. It's just a variable. This is just a variable. Yeah, so like if I printed underscore after this, it'll give me that list. Underscore is a new variable, basically. And if even here, if I just ask what is underscore, if I run this and underscore, then it'll say useless. So it's just a variable. Yeah, sorry about that. Yeah, it'll make, yeah, I guess this is a nice catch.
I have a question.
Right. This won't work. Yes, go ahead.
So why would underscore give you useless if the variable you stored the list of useful, useless includes x, y, and underscore?
Right. So what I'm doing in this code, right, is that x, y, and underscore is the 3 elements of this list. So x becomes useful. Useful, I guess useful 1, useful 2, you could say, like it just to differentiate. So useful 1 is x, y is useful 2, underscore becomes useless. And it's just a convention to use underscore for a variable that we're not going to be using. Does this assignment make sense to you, by the way? This multiple assignment?
I thought it did, but now I'm a little confused because
okay, I can show
x, y.
Yeah. So I could do something like this. right? So I could do something like this. So xy equals 5, 6. I could put this in a list as well. So x equals 5, y equals 6. Does this part make sense?
Yes.
Right?
Okay.
Now, suppose I have a third thing here, or I guess not a third thing. Suppose 5 is useful, 6 is not useful. Right? Maybe in sometime down in the code, what I'm doing is what I want actually is like 100 times x. That's all I care about. But for some reason, some function is returning this, or somehow I have this thing which I need to get the first value from, and then use that. So instead of saying y, I mean, the code will still remain the same, but it's a convention to name useless variables by underscore, so that you're being explicit that, this is a variable that I'm not going to be using in the rest of my code. So yeah, that's why. Does that make sense?
Okay. So what if we just put x is equal to 5, 6?
Great question.
That
So
would
what if I
mean,
said x equals 5, 6? Like that, you mean?
yeah,
Well,
because
then x will be just like what we did. So then x will just become the list, basically 5, 6. And if I did something like this, then it'll do the same thing. It'll make something like a list, a tuple, but like similar to a list, a collection which contains both 5 and 6. Like that.
okay, so when you store any value in a variable
Mhm.
that's like a combination of different like x and y,
Yeah, like
it
elements, different
depends
elements.
on, it correlates the position of x and y to the values stored in x and y.
Yeah, that sounds correct. So yeah, so if I had x and y, then it'll um, say that x is 5 and y is 6. That's multiple assignment. It's um, kind of like a fun trick in Python, basically.
So what if you put, I'm sorry,
No,
x comma y.
comma y. Yeah, that is very interesting. That'll be fun. Let's see. Let's see. What do you think?
No, but without adding 7.
Without adding 7? Well,
Yes.
then it's gonna give me an error. Yeah, so okay, let's try that. It says not enough values to unpack, and that happens. That's a common error to see. On right, you have only 2 things to assign. On left, sorry, yeah, on right you have only 2 things to assign, but on left you have 3 variables that need an assignment. So that's gonna say, yeah, and same is gonna happen if I said like 5, 6, 7. If the number of assignments is not equal to the number of variables, then it's going to give me error. Too many values to unpack, expected to. So it has to be like that. Great question. But I'm also interested in this, actually. Not what if I did this? What do you think it'll do then? Any thoughts, people?
5, 6.
I think it could be that, yeah, but I think like the last y should probably change the value of y.
Yeah. 5, 7, yeah.
But I'm not sure, actually. I'm really not sure. Oh, okay, yeah, I guess that. So the order basically matters. So like if I said like X and then I said like a string, then it'll be DFT7. Yeah, okay, that's pretty cool. That's pretty cool. I don't know why I would use that, but it's still pretty cool. Yeah. Yeah, I think your learning gets maximized when you start enjoying these things. It's Python has so many of them. Like a common thing to do in Java or like any programming language is that, okay, you have A equals 5, suppose, and you have a B, and you have to swap them, right? You have to swap them. Now, if you were in Java, you would say, let me make a temporary variable, and you would say temp equals whatever A has, then you change A to B, and then you change B to the previous value, so B to temp, and then you say what's A and B now, and then you have the swapped values. But in Python, what you can do is, so screw all of that, just AB equals BA, and that'll swap them. That'll swap them. That's a very fun trick. And if you suppose you're giving a coding interview, and if they see this, that's pretty cool to see, I think. I mean, it still doesn't show like you have you're a good programmer or something, but it definitely shows that you have nice experience. You know some fun tricks. It's fun to watch. Yeah, it can create an impression, in my opinion.
Could you control Z a few times? Because I saw something that
So
threw
I'll
me off.
undo. You tell me when to stop.
Okay, go back.
Okay, sorry. Where? Oh, this thing?
Perfect.
Oh, this one? Okay.
Stop. So you change the value of A from 5 to temp, and then you change the value of A
I changed the value. Well, I defined temp first. I assigned 5 to temp.
Oh, okay. You did.
Remember,
so
assignment operator assigns whatever's on the right to the variable on the left. So it's always like right to left. Yeah.
Okay.
Yeah. It always goes right to left. So it takes the value from right and it assigns it to the variable on the left.
Okay, so temp equals 5 and B equals 5.
At this point, yes. So print, well, you mean at the end here, right? So temp is 5. A becomes whatever B is, so that's 4. So both A and B are 4. Then B equals temp, so B becomes what temp is, and that becomes 5. So that's how you swap them in Java, or like I mean, without using the cool Python trick. That's how you swap them, basically. That's what I meant.
But why would
Why do this?
the product being printed be 4, 5 when we redefine what A and B are? A is equal to B, and A is 5, which means
No,
B is
so
5.
again, the assignment is going to go from right to left. So whatever B is,
Okay.
that goes into A. So B does not change at this point, right? Yeah, so that's something I could have probably emphasized more when I was talking about assignment operator, that it assigns the value on the right to the variable on the left. So value on the right, variable on the left. Whatever's on the right has to be just the value. In fact, you cannot have something that's not defined on the right, as I showed you the example of that new variable, remember? So the value of that goes into whatever's on the left, the variable on the left. So the thing that you're defining has to be on the left. It matters. It's not a communicative operator, you know. It's very much directional. It has a single direction. The value on the right goes into the variable on the left. So when you change A to B, B is the same until you actually change B by filling it with the previous value of A.
which is
temp.
4.
So this is previous value, basically. This is the previous value of A. Original, I guess, original value of A. That's what temp stores. That's why we need temp. We don't even use temp if further down, but it's just so that when we change A, we still have the value of that original value of A stored somewhere. Does that make sense?
Yes. So I'm just trying to, in my mind, make sense of all these variables. So
Yeah.
temp is A, which is 5.
Right. Right. So it
And
becomes
then
5.
A is B, which is 4.
Yes. So B is 4 and A becomes 4.
And B is temp, which is 5.
Yep. Temp is 5 because that's the original value of A. Right. So
Okay,
temp is 5. So
the
B.
new AB is 4, 5.
Yep.
No, the first AB is 5, 4, right?
Well, originally it was 5, 4. And I want to swap them. I want to make A equal to what B is, B equal to what A is.
Okay.
Yeah, that's what swapping the variables means. So A should become 4 and B should become 5. Does that make sense?
Yes.
Right. Yeah, but
Thanks. Yeah.
yes, but then you don't need all this. Yeah, you don't need all of this code because in Python there's this trick that you can just do this, right? So you can just comment this and then say AB equals BA and then you're done. You can do it.
But I have a question though.
Uh-huh.
So the first print of AB should be 5, 4, but it didn't print 5, 4. It printed something else.
Which one? This one?
Yes.
Well, that
Because we
shouldn't be
swapped
5,
them.
4 because so in this line, right, I've changed my A to what B is. So A,
Right.
why will A stay as 5, right? A will become 4. Because I changed A to whatever B is.
Right. Which is 4.
Yep, so 4.
And then B
And then B is
is
not changed. We never changed B because B has never been on the left side of the assignment operator yet.
okay, so it's 4, 4.
Yep, 4, 4. And then when we change B to temp, B becomes 5.
Right? Because temp is A.
Mm-hmm.
So whatever temp is, which is the value assigned to A, which is 5,
Mm-hmm.
is now turned into B, the value of B,
Yep.
which is 5.
That value is passed on to B. Exactly. Yeah.
And A is still B, so that's 5, 5.
Yeah. A is what B was at this point. Changing B after this does not change A as well.
So A
Yeah, A is what B was originally. We changed
okay.
B, but that does not change A again.
Okay.
Yeah.
I see it.
Yeah.
Thanks for your patience. I appreciate it.
Oh, no worries. Yeah.
Thank you for coming out.
Yeah, for sure. I mean, I've totally been there myself. It's very confusing to begin with. But you know what? You're all doing a great job. Honestly, coming here was the first step, I think. And next week, weekend or next weekend, sometime that I'll tell you by Tuesday, we'll complete this lesson and we'll be all ready to start coding in Python. It'll be amazing, literally. when you start coding in Python, right? When you start writing codes like this, it's just amazing. Yeah.
Yeah. Could you help me with MySQL?
MySQL?
Yeah.
I'm actually making a lesson on SQL for the data science committee.
Dude, okay, dude. This is my first time trying to use it. I'm trying to query the US like SC like the genome browser. Dude, let me share my screen.
Oh man.
Thank you for teaching us Python.
For sure, for sure. Yeah, thanks for coming again. Have a good
Thank
one.
you guys. Yeah, could you
All
let
right,
me share
Calvin,
my
I
screen?
can
Yeah.
enable screen sharing. Sorry about that. Yeah.
Yeah.
Yeah, go ahead. Go ahead.
Are you still recording, by the way? I'm not sure.
What? Oh,
Just wanna air
man,
this out to
bro.
everyone.
I thought it stopped at some point.
Oh, I think it's still